Hey everyone, in today's video we're going to talk about the filter section. Just a reminder, make sure to hit the subscribe button, check out my Patreon page in the description if you want to support my channel, and get my PDF patch books. I'd really appreciate it. So in subtractive synthesis, filters are essential tools that we use to sculpt our sound, and the Matriarch has a really unique and flexible approach to filtering by offering two filters as opposed to just one, and giving us some signal routing options, and that gives us a lot of control over the shapes and types of filters you can get. So right here we have the cutoff, which sets the frequency of the filter, and there are two resonance knobs, one for each filter, and that gives us a bump at whatever frequency the cutoff is set at. You can actually get these to self-resonate if you turn up these knobs high enough. This is the spacing between the filters that changes the cutoff amounts for each of those. We'll get more into that in a second too, and I'll explain why that's relevant. Down here we have the envelope amount. This will tell us how much the envelope will impact the cutoff of the filter. And that of course depends on how you set up your VCA mode right here, and I'll explain all that in a second. And the last knob we have is keyboard tracking, and this actually sends out the volts per octave control voltage to the filter cutoff. If you remember the video on the keyboard, we have a patch point in the back that gives us the voltage from the keyboard. Turning this up is essentially the same as patching from that point into the filter cutoff. So as you play higher notes, the filter moves up. But before we get to all that cool stuff, one aspect about this particular filtering section that confuses a lot of people at first are the different modes. So that's where I'm going to start. And from there, we'll explain all of the other parameters and how you can use them. So there are three different modes: series, stereo, and parallel. And for each of these, the signal is routed differently. Also, you'll notice that on series and parallel, the first filter is a high pass filter and the second is a low pass filter. Let's start with the one in the middle, stereo mode. The reason I'm starting here is I think this will make the filter act in a way that is probably familiar to a lot of people. Because both the filters are acting as low pass filters, the sound discrepancy between them is minimal. So it's essentially acting just like one low pass filter. The only thing to keep in mind is that when using this, filter 1 goes to VCA1 and filter 2 goes to VCA2. So it creates a true stereo path, and it matters for two reasons. First, if the resonance knobs have different values, then it'll be noticeable on the left and right channel. Listen for a second as I crank the resonance on only the second filter. You should hear that whistling sound only in your right ear. If they are set to the same level, although they're acting separately, the sound that's produced is going to be the same, so you won't really hear any difference. So the other thing to keep in mind is the spacing knob. This will play a bigger role in the other filter modes. In stereo mode, I generally leave it at the 12 o'clock position. However, there might be situations where you want to change that. The spacing knob controls the offset between the filters. So that what that means is that filter 2's cutoff will stay at whatever frequency you set it at, and filter 1 will move. If you turn it in a positive direction, the cutoff for filter 1 will be higher than the cutoff for filter 2. If you turn it in the negative direction, the cutoff for filter 1 will be lower than the cutoff for filter 2. So how could this be used in stereo mode? I could see possibly a mixing situation where you have an instrument panned to one side and you want that side filtered more, perhaps. But as I said before, in stereo mode, I generally leave it at the center position. In the other modes, however, the spacing knob has a huge impact and is essential for shaping the filter. So let's talk about the differences between these two modes. They have the same high pass and low pass combination. Filter 1 is a high pass, filter 2 is a low pass. The ingenious part of this filter is the signal routing. So remember in school talking about comparisons using terms like union and intersection? The same concept applies here. If we look at this Venn diagram, the union of the two sections is the totality of both circles. The intersection is only where they overlap. For our filters, we have a high pass filter and a low pass filter. If we think about how the signal passes through them, we can see that one of the modes is a union and the other one is the intersection. So in series, the sound will pass through filter 1, leaving us with this sound. Then it will pass through filter 2, which will filter the signal even more and leave us with this. This is the intersection of the two filters, and you might recognize this shape as a band pass. Many filters in Eurorack modules have band passes built in. If you take a look at this filter from Nokia Circuits, it's a multi-mode filter, and notice this knob, I can change between low pass, band pass, and high pass. That band pass shape right there is the same shape that's created by the intersection of the high pass and low pass filter in series mode on the Matriarch. Now the spacing knob allows us to further shape the band pass. More so than many band pass filters, we can make it a really wide band with only the highest and lowest harmonics filtered out, or we can make it a really thin band. Let's listen a little bit. See how that's a really thin sound? And as we get lower, it starts to thicken out a little bit. In parallel mode, the sound passes through filter 1 and filter 2 at the same time in parallel. So this gives us the union of the two filters. The sound from filter 1 will pass through as filter 2 is passing through. If they overlap in this case, you'll still hear the entirety of the sound because although filter 1 is filtering some of the harmonic content, it's still coming through on filter 2 and vice versa. So how is this used? If you move the spacing knob in a positive range, the high pass filter is higher than the low pass filter, and you're left with this shape, which is a notch filter. That can give you some really hollow sounds with some lower harmonics and upper harmonics, but it really cuts out the middle area. So you can see that the way these signals have been routed gives a tremendous amount of flexibility. You can use the different filter modes to make low pass, high pass, band pass, and notch filters, covering all your filtering needs. Plus, you can use the patch points to route these to different areas and modulate different parts of the filter. So it's just a really great design for a filter. Before I talk about the patch points, let me demonstrate the envelope amount for you. I'll set it back to stereo mode, and let's have our VCA mode in amp envelope. So that means the labels here are accurate. So this is the envelope for the volume of the sound. This is the envelope for the filter, which this is an attenuator for this. So notice here, I've got a fast attack, a moderate decay, and I'm leaving my sustain up. And on the filter, we're gonna have a fast attack and a slower decay. In fact, let's turn the sustain all the way down and the release, and we'll set the release at the same amount. So the only real differences here are the sustain's all the way down and the decay is slightly lower than the other decay. Now notice with these settings, when I play something, I don't hear anything, and that's because the cutoff is all the way down. But if I turn this up, what happens is that the cutoff will be modulated by the envelope for the filter. Actually, I'll turn the delay all the way down. Now notice it's really fast, so let me put this up. So what's happening here is when I play the note, the attack is so fast so it instantly brings this knob up and it comes down at a slightly slower pace back to its original setting. If I turn this to a slower attack, this is a great setup for making classic bass sounds where you turn the cutoff all the way down, you turn the envelope amount up, and you have a fast attack on both envelopes with a slightly slower decay on the filter. And then you could even turn up the resonance to make it a little bit more funky. So let's talk about the patch points. Like all the sections of the Matriarch, you can use them as standalone Eurorack modules. Here, the VCF ins and outs are where you would be able to add signals if you wanted to use this filter separate from these oscillators. So if you had a whole Eurorack system, you could plug them in and out here and use this filter with your other modules. Or if you wanted to patch particular oscillators to specific filters, etc., the cutoff frequency patch points essentially moves this knob. If you only patch into cutoff 1, it's normal, they're hardwired to cutoff 2, and you don't have to modulate them both. If you plug into cutoff 2, it won't modulate cutoff 1. Here, you can modulate the envelope amount knob at this patch point. So there you go. That's the filter section. In the next video, I'm going to talk about the envelopes.